This is limits involving trigonometric functions. Let's go through them. Then from there, then we'll talk about continuity. And then from there, we'll move on to that section that talks about the derivatives. Now, please work out number 17. Find the limit of sine of 2x minus 4 all over 5x minus 10 as x approaches 2. We are continuing from where we left off a few days ago. The last question that we tackled in this section was question number 15. These exercises are focusing on limits of trigonometric functions, if you still remember. Yes. So we are continuing. So the exercise that we are beginning with is number 17. The limit of the sine of 2x minus 4 all over 5x minus 10 as x approaches 2. Lerato, what did you get, my brother?
2 over 5.
Hello.
Hello, Level.
Yes, sir.
What did you get as an answer?
2 over 5.
Huh?
2 over 5.
Oh, wow. Theo, what did you get, brother?
I got 2/5 as well, sir.
Level, Lerato, Theo, let me thank you for having found what we were actually looking for.
Yes,
We're indeed looking for 2 over 5. Hello, sir, how are you? Hello, someone called me. Hello. Person disappeared. And now we continue. Okay, level 1. Can we then
continue?
Yes.
Yes,
Can we then look at number 18?
Okay, sir.
Yes. Let me say you have got 3 minutes.
Sorry, Glenn, Vuyo's hand is up.
Hello, Vuyo.
Yes, sir. Speaking to Vuyo.
Yes, Vuyo.
We were doing number 17, isn't it?
Yes, we are done.
Yes, I got the answer.
To be?
2 over 5.
Yes. You got what we also found.
All right, sir.
And now we are working out number 18, the limit of the tan of x all over 3x as x approaches 0.
All right,
yes.
Thank you.
Okay. Lungile, let me start with you. What did you get as an answer?
If I'm not mistaken, I got 0.
You got what?
I got 0.
You got 0.
Yes.
Thank you. Where should I go? Okay, now let me go to the top. Lerato, what did you get?
1 over 3.
1 over 3. Levo, what did you get?
1 over 3.
Vuyo?
Yes, sir.
What did you get as an answer?
I got the answer as 1 over 3.
1 over 3. Ndumiso?
I got 1 over 3.
1 over 3. Theo?
I got 1/3, sir.
1/3. Lungile?
Yes.
Yeah, you and I need to sit on this table and talk about how you got how you got the 0. Please explain to us how you got the 0.
Okay, I think I might have been mistaken because what I did was I took the 10x. The 10,
Lungile,
can you? Oh, sorry.
Okay.
Can you hear me?
yes, what it doesn't mean that Lerato, Levu, Vuyo, Ndumiso, and Theo, it doesn't mean that what they got is actually what we are looking for. Okay? And it also doesn't mean that what you got is not what we are looking for. Okay?
Yes, I
Yeah.
understand.
So we must believe in ourselves and in our answers. Thank you. So now please share with us how you arrived at this answer.
Okay, so what I did was I took 10x and made it sin x over cos x. And then I took 3 out. So it 3x out. But I think I made a mistake here. Instead of taking 1 over 3x, I don't know, I need to rework it out because what I did is after 10x over 3x, I said limit where x is approaching 0. I said sin x over 3 times cos x, and then I separated them. I had sin x over 3 times 1 over cos x, which gave me 0. So I think I might need to work it out if it's not correct. If it is, I guess.
There is no correct or not correct where we are. Okay.
Okay.
That way doesn't got any space. And it will never ever find a space where we are. We haven't got a space for that way. Thank you, Longile. Now, thank you for the explanation. Now let me come here. Okay, there is Lerato, there is Levo, there is Ndumiso, there is Theo. Let me not choose. Can any one of you share with us how you arrived at 1 over 3? Anyone?
Okay.
Hello?
I was taking and there was someone taking again.
Who's talking?
It's label.
Yes, Levo. Do you want to go for it?
I don't know if Theo wants to go for it. Theo?
Sure, I can do it.
Okay, go on.
Thank you.
Okay, so initially I subbed in 0 to the equation and then I got 0 over 0 and that didn't work, obviously. And then what I did is I just literally applied L'Hopital's rule where I derived the top and the bottom, and the derivative of tan x is secant squared x and the derivative of 3x at the bottom is 3. At that point, I then subbed in the 0 and then I got secant squared of 0, which is 1. And then at the bottom I had the 3 and that's 1/3.
Theo?
Yes.
Which module are you doing? Is it 1512? Math
Yeah,
1512?
I'm doing 1/5
Yeah, and I hear you saying you are using L hospital rule.
Yes.
Is not applicable.
Theo. Yes.
We don't use L hospital rule. Did you hear me, Theo?
I hear you.
Yeah, so can you just explain it to him that we are not using L hospital rule?
And if I may ask, why are we not allowed to use L'Hopital rule? Because it's derivatives, as far as I'm concerned.
Yes, for our standard is not.
Okay, so do you mind explaining why we can't use L'Hopital's rule to derive?
So Nick, can you just take it that one?
Okay. Anyone before I come in?
Me.
I try.
But,
Yes, Lelo.
okay,
Um,
the
I
first
think
thing, there's a law that we learned that sin x over x is equal to 1. So I separated sin x into two parts. Sin x times 1 over cos x over 3x. And then sin x divided by x gave me 1. So I had a side which was 1 over cos x over 3. Cos 0 is equal to 1. 1 times 1. 1 divided by 1 is 1. So I said 1 times 1 over 3, which gave me 1 over 3.
Yeah,
Okay, so you
Lakato.
basically applied the power series rule. Okay, cool.
Lakato.
Yeah.
Theo
That-
was asking why we are not allowed to use El Hospital rule. So I thought we were answering him.
Okay, Theo, we are
Yeah.
not allowed to use La Hospital's rules because people are doing these modules. Some of them are not doing the 1612, they don't understand it. And also, they said in this module, we are not allowed to use it according to what I heard. So that's why I also stopped using it.
So instead, okay, I guess in that case, we'd have to use the power series rule the same way you did it then. Then you just get to the same
Power
answer.
series rule,
Yeah, which is basically
compounding.
what you did.
Yes.
Yeah.
those things.
Yeah, so sir, Minya.
Hello. Yes.
So am I going to be incorrect if I on the exam I'm using El Hospital rule?
El Hospital is not part of this module.
Am I going to be incorrect?
Yes.
No marks.
No, man.
Once we start to see it in this module, not being part of this syllabus, not being part of the syllabus for this module. No.
So may I ask? So the guys that are doing the other calculus module, are they then allowed to use the rule for their module?
Yes, I know. There are modules where El Hospital rule is applied.
Yeah, like
But not
1613, I'm assuming.
I can't remember that module, but that module has to do with these integrations and derivatives. Aha.
Oh, interesting. Okay.
Now, what was used in here, Lerato, thank you for the explanation. Goes back to the application of this. But then this, now we had to write it in this because it was not in this format. Do we agree?
Yes, I agree.
Yes, sir.
Thank you. Yes, okay. As long as we agree, because it was not in that format. Only thing that we had to do was to write it in that format. Now, let's look at number 19. The limit of the sine of 2x minus 2 all over x minus 1 as x approaches 1. Level?
Yes, sir.
How many minutes will it take you to solve number 19?
2 minutes.
Huh?
2 minutes. It's fine.
Okay, so are you saying now we are agreeing that we are allocating 2 minutes to number 19 for it to be worked out?
Yes, sir.
Okay, thank you. Lungile, We were working out number 19, ne?
Yes.
Do we agree? What
Yes.
did you get as an answer? Yes, thank you. What did you get as an answer?
Number 19. What I got
Number
as an
19,
answer
yes.
was 2.
2.
Yes.
Lungile, are you sure about this number 2?
I'm trying to work out. Okay. Can I explain again what I did?
Whoa. You will be the first one
Okay.
to explain to us. But are you
Okay.
sticking with this 2?
Yeah.
Oh, okay, thank you. Lerato,
Positive 2.
positive 2. Vuyo,
Yes, sir. It's
Vuyo.
2. It's 2, sir.
Levo. Thank you, Vuyo. Levo.
2. 2.
Ndumiso. Ndumiso. Theo.
I got two,
I
sir.
got 2,
Sorry.
sir.
Oh, Ndumiso is
I
got
got
2.
2.
Theo, what did you get?
I got 2, sir. And yes, I didn't use L'Hopital's rule this time.
Oh, okay. Thank you. Thank you.
Yes, I did not, but I got 2.
All right. Thank you. Let me ask my sister Lungile to explain to us how she arrived at this answer.
Okay. Okay. So how I arrived, right, is since 2x minus 2, when I take out the 2, it gives me x minus 1, which is the same as below, x minus 1. I just on the next line I said limit x minus 1. I mean limit where x approaches 1. It will be sin 2x over x, just to simplify it, right? And then I went next line, limit x approaches 1. We have sin 2x over 2x times 2x over x times x over sin x, which is just a way for us to separate it so that we're able to work with it. And then that will give me 1 times 2 times 1, which gave me 2. Yeah.
Hang on, Lungile. I think you were too fast for me.
Okay.
Yes.
Okay.
Do you mind?
can,
Do you mind repeating?
yes, I can start again. Okay.
Please.
So from the equation, I tried to simplify it. So I made that sin 2x minus 2 over x1 to be sin 2x over x, just so that I can work with it in a simpler manner. And then
You wrote it as in the you wrote it as sine.
sine 2. Well, the symbol I used was x. It should have been different, but it was easier for me to work through it if I said 2x instead of theta. So I just said sine 2x over x, right? And then
Hang on,
to simplify.
hang on, anyway. I'm not. Someone once used another way to say no. I'm putting. Yeah, I remember it was a him saying I'm putting him on the spot. That is not the idea. That is not the idea here. Ne?
Okay.
The idea is to make sure that we understand things the way we should, and all of us understand them. And we do things the way we need to be doing them, the correct way. So let's say from this step, you see from number 19, the way as it is. Ne? What will be your next step? I need to write down what you wrote, all the steps.
Okay. Okay.
Yes.
The next step, I wrote limit where x is approaching 1, right? I wrote sine 2x over x.
Sine 2x all over x.
Yes.
Not x minus 1. Ne?
No, just I tried to simplify it by saying
Okay,
2x.
all over x. Sine, open bracket, 2x minus 2 all over x. Eh?
No, I just signed 2x all over x. So from the equation, I said sine 2x.
Okay. Lungile didn't finish your explanation. Okay?
All right.
But
It's my
do you
platform.
agree with the way, with the explanation in the next step from the given exercise?
Mm-mm. I don't agree.
Yeah, I also don't agree because I got confused. That's why I asked her to explain so that we can be able to help each other out.
Yes. Because she was saying she simplified that equation into sine x over x. So I really don't get it why she did that.
Say,
Hello? Hello?
I think like,
Yes.
yeah, I think in the first question, he had like that rule. I don't know what Theo calls it, the one for sin x over x. And then she tried and
Mm-hmm.
applied it. But unfortunately, she applied it in the wrong, because she was like,
She didn't apply it in the wrong place.
she
I
applied
can
it in,
say
with a sin 2
no.
over x, separated from the whole equation. And then you write -2 over 1. That's how
Negative
she,
2 over 1.
Ukabutsa said, she said sin 2x divided by x, and then separated everything.
Separate
That's why.
negative 2 over negative 1 ela.
Yeah, like who separated school addition of fractions. I separator in the middle of the signs. She did exactly that, like sin 2x, separated it from -2 divided by x, and then dilute -2 over -1.
Yeah, which was also wrong even if I used that method. I
I
say
will,
on a yeah.
yeah, sorry, wrong, Mare.
Yeah, okay, I can choose because that's all offline.
How thing, peace.
Oh,
Lungile, are you back or are you gone?
she's gone. She's now muted
She's
and offline.
Usendile working, go to chat. Oh,
Oh,
there's a lot. Yeah, yeah.
yeah, but she must get in here so that we can help.
Like,
You say she
you
sent
can see
her working on the chat.
on the chat, you can see what she was trying to do, but like, it was the wrong moment.
Okay, Lerato, let's say from her working,
Yes,
her
sir.
approach, is it the way this exercise should be approached or not?
It's completely wrong.
Okay.
Yeah, the solution is for us to explain. Even there are some others who did it wrong. So if we can explain it how we got that too, maybe others will be on the light.
Okay, I hear you, Level. Then, are you...
Hello?
Okay.
Hello?
Hello.
Who's talking?
Hello?
I hear the
Okay,
hello.
fine.
Yes.
Can you guys hear me now?
Yes,
Can hear
Lindy
you. Who's
left.
talking?
Lindy.
It's
Okay.
Zungile. Okay, I was saying I came back and I can hear that you're saying you want me to explain the equation better. Do you want me to do that?
please, so that we can help you.
Okay. Okay.
Because you took the route that you were not supposed to take. We want to help you.
Okay. Okay, so where I left it was limit x approaching 1, right? Where it's sent 2x over x, like the picture I sent. X is approaching 1. The next one, I said x limit where x is approaching 1. I said sin 2x over 2x times 2x over x times x over sin x. And then when now I was supposed to what is it? Substitute where x is approaching 1. I got 1 times 2 times 1, and that's why I got 2.
My sister,
Mm-hmm.
the road that you took, we want to go to Rome. That road will not take us to Rome.
Okay, so where I got this, and maybe that's why I can understand if I'm wrong, is from the textbook, where they use theta instead of x, and maybe I should have done that, but I was trying to follow the example that I got from the study guide.
Is it the first time you join us in these workshops?
Yes, unfortunately, they usually are during my working hours. It's the first time where I was able to join in properly.
Okay. We are a caring family here. If you heard at the beginning, we were greeted as a family. We are a family here. We are a caring family that helps out each other. Your explanation, we disagree with your explanation, even though you might have found what we were looking for as the final answer. The way you got to the final answer is not the way you should have got there. Can I, at this point in time, before I explain, I can, but now, as I said, we are a family here. I will just ask anyone amongst us to explain to Lungile how we got that answer. Anyone?
I can explain. Levi can explain.
Lungile.
Okay.
Yes. Can you hear me?
Anyone level? Lungile.
Yeah.
Please listen attentively the way Lebo will explain how we got the answer.
Okay.
Thank you, Lebo. Please go ahead.
Step number 1, and I said 2 divided by 2 multiply by sign 2x minus 2 divided by x minus 1. This 2 over 2 is that 2, you see that have x, Lungile. Hello, Lungile.
Yes, sorry. Yes, please repeat.
I'm saying 2 over 2 that I used is the 2x. I took that 2 of 2x. If it was 3x, I was going to say 3 over 3. You understand?
Okay. Yeah.
And then next step, my denominator, I multiply it by 2, which is that 2 over 2. My denominator now is 2 bracket of 2x minus 1. You agree with me?
So you say your denominator is now 2 brackets 2x minus 1.
No, I'm saying my denominator is 2 multiplied by bracket x minus 1, close bracket.
Okay.
Yes, and then my numerator is 2 sine 2x minus 2. You understand?
Okay.
Yes. Now, on my denominator, I multiply that 2. Actually, I'm removing that bracket, which is I'm going to have 2x minus 2 on my denominator. You agree?
Okay, I understand you.
Yes, and then on my numerator, we'll be left with 2 sine 2x minus 2. And if you can see, whatever you were doing, no, it won't be the same. If you can see, sine 2x minus 2, you can divide it by 2x minus 2, which will give you 1. It's like you are saying sine x divided by x. By this time around, our angle is 2x minus 2 divided by 2x minus 2. You understand?
Okay, yes, I understand that now.
Which that thing will give you 1. And then 1 multiplied by that 2 we are left with on our numerator is going to be 2 multiplied by 1 is going to be 2. Now you understand.
Yes, I completely understand.
Now you see your mistake.
No, I understand it now. Like I said, I think I was confused by the textbook because I was trying to follow it, but I understand how we got to that.
Where in the textbook? On page what?
Let me send a picture.
Sorry?
So I'm saying, let me send a picture.
Okay, what textbook are you using? Which one?
It's the study unit, number 22, page 27, number 47.
Oh, it's a study unit. Study. Oh, okay. Anyone who have it? Oh, can you please share it on? Because I don't have it on. Can you please take a picture?
She already sent it on the group.
Oh, picture them on the
No.
chat.
Yes. She was referring on that example on study guide, ne? And ntho ke try go etsa gore ke batla mo explainela from more. So yena o copile ntho wrong a entse mo. Wa understand?
Okay.
Okay.
Yeah, o tshwere study guide ma o etsa. She's copying that thing to the go like ntho e seng similar le that example.
Can I try and help her a bit?
No, I see.
Okay.
I see where I went wrong. I completely see where I went wrong. Whereas like this example is sin over sin. Na getakare, it was exactly like that when it's not the case. Whereas this example you took me through makes sense. I see where I went wrong.
Yeah, wa bona no jole na. Okay, sharp.
Thank you so much.
Do you now follow Lungile?
Yes. No, now I follow. I see my mistake though.
Okay, thank you. Level?
Yes, sir.
Yeah. Now, Osha, thank you for the explanation.
Thank you, sir. There's
Yes.
someone who raised a hand. I don't know who is he or she. A hand. I see a hand on my screen.
Yes, good afternoon, family.
Afternoon, family.
It's Mbongs. It's Mbongse.
Yes, Mbongse.
Yes, I'm sorry, I joined late. When Lebogang was explaining, I caught her towards the end. I'm missing something. That 2/2, the very first 2/2 that she started with, that's where I'm losing her. Can you just explain that, please?
Yes, that's where I was saying that 2/2, those two, I took it from here, where is 2x? I took that 2. If it was 3x, I was going to say 3/3. You understand?
So you took...
Okay, if it was sine, let's say sine 3x minus 6, ne? Understand?
Yes.
I was going to say 3/3 sine 3x minus 6, because at the bottom I want to make this x minus 1 to be 2x minus 2, because I have this rule that's saying sine x over x is equals to 1, which is that x is my angle, and then now I have the angle of 2x minus 1. So my angle supposed to be the same as the angle that I'm gonna divide with, which is, now I'm having 2x minus 2. I want to make this x minus 1 to be 2x minus 2, so that I can say that thing is equals to 1. You understand?
I got it. Thank you so much. I got it. So basically, you just multiplied that thing by 1, which that 2/2 is actually 1, because you wanted to make that denominator to be 2x minus 2. So that is the same as the angle.
Yes.
Thank you so much.
Thank you.
Let me thank you again.
Yes, sir. Lungile, you want to say something?
Yes, I just wanted to ask, Wabona, since it's sine 2x over 2, sine 2x minus 2 over x minus 1, would it still be the same if I took out the 2 on the sine, where it becomes 2 times sine x minus 1 over x minus 1? Wouldn't that now go that same route, where we will come back to, since sine x minus 1 over x minus 1 is 1, would it also still be the correct way?
I really don't know that one. I was doing the same way you explained this one right now. I was doing it just like that. So I realized on our textbooks and other stuff, they use this one 2/2, which is 1. So you can't take common factor on the angle. I don't know, Lerato, can you explain that one?
You can, if like sine 2 in bracket x minus 1, compound angle or double angle, I'm not sure what they're called. It's about 2 sine x minus 1 times cos x minus 1. And then sine x minus 1 divided by x minus 1, what's it 1. It's about 2 times 1 cos 1 minus 1 cos 0 ke 1. 2 times 1 times 1 answer 2. It's the same.
So if you take out that 2, now you are having a double angle.
You are not taking out that 2. We use identity at double angle or compound angle. Auntie 2. It's an allow sine squared is equal to 1 minus cos squared x. Same thing.
Yeah, Lungile was saying, what if she were taking that 2x, like not 2x, she was taking a common factor in that 2x minus 2. which is 2. Is it going to be correct? Because she's going to left with
Yes.
x minus 1, divide by x minus 1. No, it's not gonna
It's
be
correct. That
it's
way
not
it's
gonna
correct.
be correct. You know why I'm saying that? It's not gonna be correct in other cases, like this case of lim x minus 2, which is number 17.
Correct.
You see number 17?
Number 7, it's the same thing. It's correct.
It's the same thing.
Yeah, it's number 19. If you factorize and have the 2, then use a double angle. Cosine.
Last time, last time what I have done? You used a what? A compound angle.
Compound slash double. Actually, like you're
Yeah.
sure.
Double angle.
Like it's correct or factorize. Yeah.
I see what you mean. 17 and 19 are just almost the same.
Yes.
But let's be quite clear here. We are not changing the angle. Ideally, we are not changing an angle because that 2x minus 4 is an angle. Do we all agree?
Yes, sir.
But then, in this case, how should I put it? Lerado, let me say this, and then I don't know where you and I will converge, okay? Below, in the denominator, when you take 5 out as a common factor, it becomes x minus 2.
Yes.
Yeah.
Yes, sir.
And then when you take out 2 as a common factor from that angle in the numerator, we get x minus 2.
Yes. Which is the same as the denominator.
That's why we ended up getting that 2 over 5. Do we agree?
Yes, I agree.
In simple terms, that's where it is coming from.
I don't agree.
Yeah.
I don't agree, sir. You are saying now you are changing the angle. You take out the common factor, which is 2. Which is you are going to left with sin x minus 2. And then at the bottom, you are going to left with x minus 2, which is now they are the same. And you change the angle, and we are not supposed to change the angle.
Yes, we are not changing an angle. There I agree with you. Don't say level, because you and I don't say because what I said, I still agree with you to say we are not changing an angle. An angle can never be changed. It remains as it is.
Yes, sir.
How should I explain this?
Lungula is gonna take out that common factor.
Because
you are saying you are taking. It's not gonna be correct in other cases. I've tried that one.
It's correct every case.
Not other cases. I know I was using that method before. I'm using this one.
Okay, hang on. Let me share something with you. We are dealing with something like
yeah. No,
like
Manel, don't remove that one. The one
this
that
one
has red X. It's explain this thing we are arguing with.
That's why I don't want you to see it, because it is wrong. Or you want to see a wrong thing. No. You want to see what we are not supposed to do. That is not what is highlighted there, is what we must, meaning we must not fall into the trap
Yes,
doing what they did.
of taking out that
Okay.
2. You see now, they are saying you are not supposed to take that 2 out. That 2x. You see, sir, what I'm saying.
We're not doing it like that.
We are not doing it like that, but we are saying we, in other cases, we can do it like that.
No, sine 2x is equal to sine 2 sine x cos x. That's what I'm saying.
And now you are using double angle. You are using double angle and you agree with Meniel saying number 17. He can take out a common factor on the angle, which is incorrect. The way
It's
they
wrong. Like
note,
it's not. We can't do that.
yes.
I'm not doing that. I'm not doing.
Yeah.
Hey, can
You're agreeing with that.
Oh my God.
That cannot be done.
Lungile.
Is similar to this. This cannot be done.
Lungile.
Yes.
Can you see this?
Yes, no, I understand. I'm understanding now, Ore, how you did it. That's more of the correct way because Nyabonoti sin 2x is not equals to 2 sin x. I understand it now.
You are not supposed to factorize at the angle.
An angle. An angle remains an angle as it is. Is there a consensus? Is there an agreement?
Yes, sir.
Yes, sir.
Yes, there's an agreement.
Okay. Can we now proceed?
Yes, we can.
Okay, thank you. Now, let's tackle number 20 what? 21.
Lungi, do you want to give us a try? Yeah, you want to give us your answer for number 21?
Yeah. I got 1/2.
Lungi, saying my bad.
No, it's fine. Okay, okay, family. I got 1/2.
Yes. Agreed.
Buche?
Yes, sir. I'm still working on my answer. I got late, so I was still trying to catch up. So.
Okay, no problem. Dumiso?
Yeah, I got 1/2, sir.
Okay. I think we have about 4. We can try. Oh, no, more than 4. I think in the interest of time, is there anybody else who got an answer that's not 1/2? Because 1/2 is wrong. So can we get the correct answer?
1/2 wrong.
Yeah, 1/2 is wrong. So we're looking for the correct answer. Did anybody get the correct answer?
What?
Why is 1/2 wrong?
Give this man a bounce. He's
No,
pulling
man,
your
I'm
He's
just
pulling your
playing.
leg.
I'm just playing I'm giving the opportunity for everybody who might not have got it correct to actually give our answer and try so we can help each other here. There's no correct answer.
Just be key.
Yeah, anyone who got the different answer besides 1/2.
The problem is not the answer, man.
It's about.
Sir said something to Lungile. She said you got what we're looking for, but not in the
way we are looking for it.
Yeah, so I wanted to tell you how I got 1/2 at number 21.
Yes, please.
So this thing, it's sin x over sin x. So I did what I always do, angles. So I wanted to know. And then it was sin x over 2 sin x cos x.
Legend.
And then the sin x cancelled, obviously, and then it was 1/2 times 1. And then I got 1/2. Is it still fine that way, or should we do what Lebu was saying?
No, can you please explain it again,
So you have
Rato?
sine.
Start over.
It's
So
sin
here,
x all
Only
over
the
2 sin x plus x double angles.
it's a
And then,
sin x multiplied by cos x.
yeah, and the
It's a
denominator
2
sin
sin x
sin
multiplied by cos x.
is. And
Okay.
then you cancel out the sin x. It's
Mm-hmm.
met. It's okay. It's met. And then I got 1 over 2 times cos 0, which is 1. And then I got 1 over 2 times 1, which is equal to half. Instead of like that thing of saying reciprocal, what. It's confusing for me. So
Yeah, you're still correct. You're still correct. So
I hear it.
no, I didn't do it like that. I used that one that is confusing.
Yeah, please share. What is confusing with us, but don't confuse us.
May I say something?
may I also say something here?
Yeah, in that order, please. Let's allow Level, and then someone said in that order. I think after Level, then there are two guys who needed to say something.
Oh yeah, I'll go first. I wanted to say, I did it both ways, where the way where we use the absolute value of 1, we multiply the top and the bottom, and I did it the other way using the double angles. And I think the way with the double angles is simpler and quicker.
Can I also say something?
Please do.
I think with the way where you used sin x over cos x identity, what did you do? Split it into sin x cos
Cos
x.
x, yes.
Yeah, and then use your understanding of the graph to determine what the limit is. Well, that way is good for certain questions, but I think the way where you it fails you when you get something like sin 5x or sin 5 theta over sin 2 theta.
I see what you
see?
mean. Yeah.
So you might as well learn the more general way that will never fail you, and this way that is only specific to certain scenarios, you know. So the way for the way for finding an argument, I mean finding the ratio and then making the denominator the same as the argument, or making the numerator the same as the argument, so that those identities we learned in the beginning of the chapter of sin limits as x approaches 0 of sin x over x, or limits as x approaches 0 of x over sin x is equals to 1, so that you can always use those identities. So I think that's the more.
Okay, so in the essence, what you're saying is the way you're talking about it might be more labor intensive, but at least it works everywhere.
It's reliable. It's more general.
Yeah.
Than yeah.
No, I agree.
Which one
I
is
understand.
reliable?
The way you were using.
Oh yeah, like I was saying, if for those who were using double angles, so if you don't mind, can you please do number 20?
Hang on, Level. How do we conclude on number 21 before you come with your request?
1 over 2.
1 over
number
2.
21.
Okay. Lerato, what did you get?
1 over 2.
Okay, now, is there anyone who need to say something about number 21 before I come in? No one. Okay, thank you. There seems to be an agreement to say an answer to number 21 is a half.
Yes, sir.
Thank you. So, in the absence of a disagreement, I also agree with you on the half. Now, it wasn't Domeso who requested before you, Level. This was a request from from Ndumiso for us to do number 20. And then I said, let's finish 21 before we can work out number 20. So now let's look at number 20. Chanda, what did you get? Followed by Prudence. Chanda followed by Prudence.
I got 2/3.
2/3.
Yeah, well, 2/3.
2/3. Prudence.
I got 2/3 also.
Nice.
Lungile. Lungile. Is Lungile still with us?
Yes, I'm here. I got
Yes.
2.
2.
Yes, I specifically got 2.
Okay. Please stick to that 2. Lebo,
Okay.
what did you get? Yes. Lebo, what did you get?
2/3.
Thank you. Lerato?
2/3.
2/3. Ndumiso, what did you get?
My answer is incorrect. So I got 3/2.
You got
I'm
3
just
over
trying
2.
to figure out how I got it. Yes, sir.
I said to you that word, if I have got a dictionary, my dictionary hasn't got that word in it.
Yes, sir.
What is your answer?
3/2.
3/2.
Yes, sir.
Okay, thank you. Now, let's first talk to, okay, this is Ndumiso, this is Lungile, and then is Chanda, is Lebu, and Lerato. Let's first talk to Ndumiso. Ndumiso, the stage is yours.
Yes, sir.
You can dance, then we are watching you.
Okay, so we have 2x over sine 3x. So I multiplied the numerator and the denominator with sine 3x over 2x. And then from there, my next step was that on the numerator portion, when you multiply 2x with sine 3x over 2x, we're going to be left with sine 3x. Then I think my mistake was here in the denominator. Because in the denominator, when I multiplied sine 3x with sine 3x over 2, for some reason I cancelled out the 2 sine 3x's. So I believe that's where my mistake was. So I've been trying to fix it from that point.
Thank you for the explanation, Ndumiso. Ndumiso?
Yes, sir.
Brother, please introduce Lungile to the stage.
Ms. Lumila, the stage is yours.
Okay, thank you. Okay, so what I did, right, was I wanted the numerator and the denominator to be able to give me 1. So since right now it's 2x over sine 3x, I timesed both the denominator and numerator by 3 so that I'm able to have, and then so then I got 2 times 3x over 3 times sin 3x. Now it's just my issue is I made a mistake. It was actually supposed to be 1/3, you know, when now you are putting in that x approaching to 0. Instead, I said 3/3. So that's where I got my mistake, because I said 3/3 instead of 1/3, and that's why I got 2 instead of 2/3. So that's where I made a mistake, but that was my logic.
Thank you for sharing your logic with us, my sister. We have got
Sir.
different logics.
Sir,
I agree. Lerato, hang on. Still talking about logics. Ow.
Sir?
Who's talking? Is it Lerato or is it Mohammed?
It's no
Sorry?
Mohammed. No
Is it
Mohammed,
not
sir.
Lerato?
No, it's not Lerato.
Oh, sorry, Lerato, I thought it was you, my brother. No, Mohammed, hang on.
Yes.
Hang on, no, Mohammed, hang on.
Okay, okay.
Did you follow Lungile's explanation?
I didn't really understand, sir. I actually
Sorry?
wanted to contribute. I didn't actually understand Lungili's method, but then I actually wanted to contribute the answer.
I can hardly. I don't know what's wrong with your voice, or is it your voice or your mic? It's fluctuating.
Okay, let me just repeat, sir. I was saying I didn't really understand what Lungili was saying, but then I wanted to contribute to the answer.
Okay. All right.
Sir.
You are more than welcome. Always. You don't even have to ask for that. You just have to come in. Yes.
Yes,
please
sir.
go ahead.
Okay. Okay, sir. So I use label Hang's method, right? So I have 2x over sine of 3x. So I say that is equal to 2 over 2x. Sorry. I said it's 2 times 2x over 3 sine of 3x. Do you understand, sir? Are we together?
Let me follow you. What did you say? You said?
Okay, so I say 2x over sine of 3x is equal to 2 over 3 times 2x over sine 3x. Right? Then I say that is equal to 2 over 3 times 2x over sine of 2x, which is equal to 2 over 3 limit as x approaches 0, 2x over sine of 2x, which is equal to 1. Then my answer was 2 over 3. I'm not sure if that's how they did it.
I think I followed you. Thank you for the contribution, no moment.
So 2x over sine of 2x is equal to 1. So it's basically 2 over 3 times 1. So my answer was 2 over 3. I'm not sure if you understand, but I actually followed the rules on the textbook.
I hear you, sir.
Yeah.
Level where the rule, Norma Woman mentioned a powerful statement. He said he's following the rules in the textbook. Did he follow them? Did he properly follow them?
I don't know if he followed them correctly, but he made a mistake somewhere. So, yeah, you made a mistake somewhere. You know what? I was arguing with Vinyane. I was arguing with him saying you are not supposed to change the angle, and you changed the angle, which is you said is 2x, sine 2x, which is you changed the original angle.
Yeah.
What I was saying is you have to multiply with that angle. You multiply with that angle, which is angle is 3x. You multiply with 3 over 3. Yes. And then on your numerator, you are going to have 3 multiplied by 2x. On your On your denominator, you are going to have 3 sine
Mhm.
3x.
Mhm.
Now you can say on your numerator, 3.
Mhm.
Now you can say 2 multiplied by 3x. It's still the same thing when you say 3 multiplied by 2x. I think it's a multiplication.
Yeah.
You can just swap them and say 2 multiplied by 3x.
Okay.
And then divide by 3 sine 3x. You see, I didn't change my angle. I
Angle, yeah.
used my angle to have it the same as my numerator. So now I have a numerator of 2 multiplied by 3x.
Okay.
Denominator 3 sine 3x, which is 3x divided by sine 3x is equivalent to 1. Someone sent it on the chat. And then you left with 2 over 3. You understand now?
Yeah, I get it. I see my mistake.
Yeah,
Thank you.
this is how I cheated. There's someone who said this is how I cheated.
Yeah.
Mbonjeni, it's you.
Mhm.
Yes, it's me.
Ongiseni.
Mbonjiseni, this is how you
Yes.
cheated. How? How? Can you explain how you cheated?
Say it again.
Can you
You've
explain
sorry, you've
how
just
you
explained
cheated?
it.
Oh, I didn't cheat. You said you cheated. I didn't cheat. It's 3 over 3. Yeah, but you didn't cheat even though.
Say,
Hello.
has Alvin want to talk or because she had his hand up, so I don't know.
Alvin and Lerato after. Lerato, it's Alvin first, then it's you.
Thank you. Alvin.
Yes, sir.
Mm-hmm. Well, listen.
Yes, yes, sir. So why I had my hand up was because I wanted to point out Noor Mohammed's flaw with what he did in terms of the factoring.
Alvin.
Hello? Yes, sir. Can you
Yes,
hear
we
me?
can hear you. Please go ahead. Yes, can hear you.
So I wanted to point out what Noor Mohammed did in terms of the factoring. It was like wrong, but I saw that Lebu explained it properly. So that's what I wanted to point out to him, but it's fine. Lebu did explain it. He explained it anyways. So it's okay.
Oh, okay. Thank you. Then Lerato.
Sorry, Level, can you please?
And Dumiso, you'll follow up. Please follow after Lerato. Lerato, then
Okay, no
Dumiso will follow.
problem.
Okay, so I've seen miracles because I performed them. So this, you told us at the beginning that sin x over x is equal to 1, and we agreed. So on question 20, I saw sin 2x over sin 3x. So when I saw that, I thought x over sin x is equal to 1. It's a reciprocal. And then I said 1 times 2 over 3. And then I got the correct answer. So I hear that my friends are showing me, they're telling me that this method is wrong. And I'm multiplying it in funny ways that I cannot understand. When you multiply, is there like a set rule that you do this and this? If it's there, can they tell me that rule? Because like, I want to know the rules, like 2x, whether it's 2x or 19x, I want to know the rules so that I can apply them properly instead of doing what I'm always doing.
Can you start over again, Lerato, please?
Yeah, hang on. Level, I think. Okay, Oh, okay. Lerato, please repeat. After repeating, then Lebo, I'll ask you to wait. I'll ask to come in. Then Lebo, you will follow. Before Lebo, there is someone after Lerato. Who's that? Is it Indomiso? Who needed to say something?
It was necessary. Yeah, but I
Yes,
just wanted Lebo to repeat. So it's fine. Lebo can go after Lerato.
Yes, Lerato, please go ahead. Then Lebo.
Chanda. Maybe after there's Chanda's hand is up, there's Prudence hand that is also up.
Chanda,
And
Lebo.
Prudence.
I hope we'll follow the sequence, eh?
Yes.
Yeah. Okay. Lebo, I mean Lerato.
I wanted to know how to solve questions that are in this structure. K stands for a scale. Kx over sine kx. That's what I want to know. Whether it's 2 or it's 19 or it's 15. Because what I'm doing, I'm like x over sine x is equal to 1. 1 times 2 over 3, I get the same answer. The method is wrong and everything. So I want to fix that method, even if it gives me the same answer.
No, what I want to know, Lerato, what I want you to repeat what you were saying. What
Okay,
you
this is what I
used
was. Sine x over x to the limit of as x approaches 0 is 1. That means x over sine x as x approaches 0, it's also 1, vice versa. It's a reciprocal. You understand what I mean? So here, I saw the x on top and the sine x below. And then I said 1 times 2 over 3 is equal to 2 over 3. And
No,
I know
you.
that's wrong.
Oh, at least sin x. You saw sin x. It's sin 3x. Huh? How did you saw sin x? It's sin 3x. Well, one.
I didn't solve anything. I just said 1 times 2 over 3 and got 2 over 3. Nothing was solved. I used the law.
You said 1 times. You said 1 over 3.
1 times 2 over 3. That's what I said. And I got 2 over 3. Which is correct. Which will always be correct. But the working is wrong. So I want to know the correct way.
The law is ne, Lerato.
Any questions like this?
Yes, the law is x over sin x is equals to 1 and sin x over x is equals to 1. So meaning they want you to tell you that if the angle at the bottom is the same as the angle at the top of sine, I can have sine 90 divided by 90. It's going to give me 1. Understand? And then I can have 90 divided by sine 90. It's going to give me 1. We are dealing with that angle. If that angle is the same as the angle at the top or the angle at the bottom.
Which is correct? Like working yata, it correct 1 times 2 over 3. That's what I want to know.
1 times 2 over 3.
Yes,
and then
I just said
you...
x over sine x is equal to 1.
X over sine x is equal to 1. You are incorrect.
Is equal to 1.
Yeah, you are incorrect because now we are not working with 1x. We are working with 3x.
How do I remove that 3x then?
That's what I was saying. What's why ne ke batla ke khutlele number 20 ne? Ne ke batla ke khutlele for wena.
I just
Number
removed it
20.
and wrote x over sin x. The 3 I removed it just like that.
Ne ke batla ke khutlele wena Lerato number 20. You know what you have to do? That 3x, yeah, angle, ekahara side, ne? You have to multiply it, which is you're going to say 3 over 3, multiply by that whole thing.
And then toba 6x over 3 sine 3x. That's
No, you're not going to multiply that 2 with 3. You are just going to swap them. I did it a multiply. You can take x to be the first thing. You can take 2, you can take 3, but now it's 3 multiplied by 2x. And you can say 2 multiplied by 3x because it's a multiplication. It doesn't change anything. Our goal is to make sure that our numerator is the same as the denominator angle A.
Utlosa jwang 3
Ha re tlose 3 re multiply ka 3.
Like how do you make it sine x? Sine 3x we have one.
How do you make it as
sorry to disturb. There's Prudence Ari wants to assist Lerato in this regard. Maybe Prudence as well will come and assist you, Lerato, because she wrote on the chat, and Chanda and Mboniseni. I think the Mr. Mats also wants to say something today. He's quiet. Prudence, after Lerato, you'll go through Chanda and Mboniseni.
All right. So, also, are you still a bit lost, Lerato?
But the formula working alone.
Okay, so what you have to focus on, get the angle. If angle get 3, just know it's like you're multiplying by 1. So if angle is 3, you multiply by 3 over 3. If angle is 10, you multiply by 10 over 10. So basically, how change your like the problem you are feeling on.
Ooh. Your angle, you're coming right. You're not changing the angle.
I think one thing you have to understand is as long as the denominator is the same as the argument for sine x. So if it's sine 3x, you want to somehow find a way to make your numerator 3x in this particular case. So hence we multiply by 3 over 3, and then we write 3x, take the 2 to the other side. So we'll have 2 over 1 multiplied by 3x over sine 3. I don't know if you get what I'm trying to say. The objective is to make numerator the same as argument. The rest is down to how you work with your fractions.
I'll come back to you. I'm doing it right now, the way you are saying.
Yeah. I'll also write it down for you so that you see what I'm trying to say. But as long as your argument in this case is the same as your numerator, so your 3x, you want your numerator to be 3x. Where now you can get creative with how you want to do that. It's just that the way that the others are suggesting is the quickest way.
Yeah, that's why
That's 3.
So a multiplier by 3. And you're left with 3 times 2 times x over 3 times sine 3x. Now you can write 2 over 3 on one side multiplied by 3x over sine 3x. You didn't change anything, you just changed how you wrote it. Now, because the numerator is the same as the argument, we can go and apply that rule that we know. The limit as x approaches 0 of theta over sine theta, in this case, because they're the same again, is equals to 1. Hence, your final answer is 2 over 3.
Yeah, I get it now. I'll come back. Yeah, I'll get it.
You get it now. You get it now.
I'll get it after a few more questions, but I'm getting there.
You have to get it because That's why I said to Meniel, you have to go back to number 20. Reason is because of you. Because every time you are using double angle, you don't want to use this method of multiplying the angle.
Yeah, if there was triple angle, I was going to use triple angle. It does not get
Yeah. So now, Wabalianto, you are running away from this angle of multiplying it by that number, that method. That's why I said to Minang, let's go back to number 20, because I saw you are running away from this. It's either you use L hospital rule on number 20. So
yes,
that's why, huh? Yeah, you use
Like,
L hospital rule. I know well.
Bongiseni's hand is up. And Mr. Matsoso, I think, wanted to say something. If you still want to say something, Mr. Matsoso, Mbongiseni and Mr. Matsoso.
Okay, it's Mbongsen here. So, Lerato, I think number 20 has been explained. Look at number 28, just quick. If you look at the, you've got sine 7x divided by sine 5x. We don't want that 5 at the bottom, we want 7. So you can always cheat, move that 5 away, multiply that thing by 7 over 7. So your answer is going to be, I think, 7 over 5. So if the whole idea, what we're trying to do is to make sure that the angle for sine x is the same as the numerator in this case. On number 20, unfortunately, it was a denominator. A sine 3x was in the denominator. So what you do, you just remove that 5. Cheat. Just remove 5.
It's not a cheating. Don't say cheat.
The thing is, remember
like
what
that.
remember what Lerato said. When you said multiply by, when I start saying multiply by 7 over 7, Lerato is going to say, but 7 times 5 is 35. So remove that, put that 5 away.
No, it's not cheating. It's mathematics. If you multiply something by something, if you say x multiplied by y, you can say y multiplied by x. It's still going to give you the same thing. You are not cheating. Don't say you are cheating.
Okay,
If it helps him get the answer, I think let's call it cheating. If it makes life easier. Cheating it is.
Okay, thank you. I think it has been explained. Thanks, guys.
Mr. Matsuso.
I think our team almost staging, he kind of explained it correctly, even though the cheating part of it, some of us we don't understand. Maranaki understand where it's coming from. Cheat in a sense that make it easy from my understanding. That's what he meant. But yeah, he pretty much explained everything. That 7 over 7, you are just manipulating the formula to get it into a form that you want it to be, and then you can now convert into whatever identity, then find your final answer. So yeah, thank you.
Thank you.
Thank you, everybody. Lerato?
Oh,
Ndomis. Yes, Ndomis. Oh,
yeah,
no, we
so
don't.
I just wanted.
Thank you, Lerato. How we told you. Ndomis, please go ahead.
I just wanted to confirm with the family, sir. So we know that as the limit approaches 0 for the function sine x over x is equal to 1, correct? So are the guys saying that the reciprocal is also equal to 1? So I'm asking, are the guys, since we know that sine x over x is equal to 1, does that mean x over sine x is also equal to 1?
Correct.
You are correct.
Is that correct?
Yes,
sir.
Can I specifically for when the limit is approaching 0, not just every time?
Every time, my brother.
Approaching 0.
Every time, my brother. I've checked that one.
No, but the limits could
X approaches
be approaching another number.
You see now.
Every time.
As x approaches 1. It's not always going to be.
You see number 19. X is approaching 1. You see number 19. X is approaching
So
1.
now,
Huh?
so is it the same for cos then?
It's the same for cos.
No, cos has its own.
No,
Cos, okay.
yes, only for sine.
Only for sine.
Yes.
Cos,
Cos
Okay,
for
thank you.
number 16.
for cos,
Number 16, eh? You see number 16. Hello?
Level,
Yes, sir.
let me thank you for having identified a weakness that the brother had, and then having fought hard to make sure that the weakness is actually addressed. Lerato, I do believe that now you do follow how to move
yes,
around
like I follow.
this kind of
I
exercises.
get that. Yes, sir.
I liked it when she mentioned that you specifically. I came to this question for you specifically. So I like that. She identified, she realized that no, somehow you were doing things the way that were not supposed to be done. But then I thank you, Lebo, for that. Now, Lebo put on the spot for us. We are still going to test it to make sure that not only Lerato, but including the others, that they've indeed noticed how things should be done in the upcoming exercises. But for now, do you all, oh, okay, yeah. Allow me, please allow me not to talk about Level.
Yes, sir.
Please help me out here. I believe I'm in your, I think you are, if I'm in your hands, I think I'm safe. Please help me out here. Between 22 and 23, which one should we do before we call it a minute?
I choose 23 because I saw it on the assignment for 23.
23.
Yes.
Okay. Okay, thank you. May we please all work on number 23. Okay, Lebo, how many minutes?
3 minutes.
Okay, Alvin. 30
Yes,
seconds
sir.
is over. 30 seconds is over. Please share your answer with us.
I got 0.
You got 0.
Yes, sir.
Thank you. 0 is eggs. That means tonight we are going to eat eggs. Prudence. Prudence.
Yes, yes, sir.
Your answer, ma'am.
My answer is 2.
Your answer is 2.
Yes. No.
Longile. Your answer. Longile.
Hi, sorry, my answer is 2 as well.
Is it 2?
Yes, it's 2.
Abdul. Abdul.
I say I'm going with the ladies. Yeah, it's 2 by 2. I'm going with them.
Chanda. Chanda.
Lena said I'll go with 2 here because they sounds like it's the correct answer.
Hey, Bo. Hey, Bo.
No, with maths, you know when you
What's yours? What's yours, my brother?
you know witchcraft when you see witchcraft.
Yours.
Yours. We want yours.
I identify my answer being 2.
You identify your answer being 2.
Yes, I
What did you
identify
wrote?
my
You
answer
wrote
being
2.
2.
You wrote 2, and your answer is correct. You wrote 2.
Mm.
So that's
Norma woman, M1 level will come back to you. Norma woman.
Yes, sir. I got 2, sir. Number 2. Positive 2.
2.
Yes, sir. Positive 2.
People, I'm looking for a big number. I need money. Now you can't be giving
No,
me 2
sir.
rand. No.
It's 2, sir.
The answer that we and a number that we are looking for here is very big.
No,
If I can give
sir,
you that
it's
number,
2.
then you will not work for the rest of your life.
No. It's 2.
Sounds like
Positive
it's
2.
me.
I'm telling you.
Nah,
Yo, what
sir.
did you get, brother?
I got 2, sir.
Ndomiso, what did you get?
I got positive 2, sir.
These 2, I don't know who will go first, Lebo and Lerato.
Lerato is the first one.
No, Lebo, go first.
Lerato, what did you get?
X plus 1.
X plus 1.
Mm.
Is that your answer?
That's my final answer.
Thank you, brother. Lebo, what did you get?
X plus 1.
X plus 1.
Yes.
As the final answer.
Yes. Huh? Not so.
Abdul? Abdul, we can't hear you. You're breaking. You're breaking, Abdul. Alvin.
Yes, sir.
Alvin?
Yes, sir.
How do you please Okay, Alvin, don't disappear. Abdul.
Still here.
Abdul. 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 Okay. Now, Alvin.
Yes, sir.
Yes. Please share with us your explanation of how you got to 0.
So I applied the limits a bit too early.
Can you hear me now, sir?
Alvin, hang on. Let's talk to Abdul. Abdul. Abdul.
Matsuso.
Matsuso.
Load shedding. And a network.
Yes, sir.
Oh. Abdul. Abdul. Okay, I'm stepping off Abdul. Alvin.
Yes, sir.
Yes, we are listening.
Okay, so I think I did something wrong here. I applied sine. I factored out sine and went straight to limits as x tends to 1 of sine x squared minus the limit as x tends to 1 of 1 all over x minus 1. Are you following?
I'm listening. Lebo and Lerato.
Yes, sir.
Oh. Are you sure that is your final answer?
Yes, sir.
Sir,
Yes.
my answer still has limit x as it approaches 1 on the side. Like it's limit x as it approaches 1. The limit of x plus 1, x approaches 1. That's
Oh,
what
yes, sir. 2.
I haven't substituted at all. It's just limit x plus 1 as x approaches 1. That's what it is. So now I want to change and substitute the x for 1.
Mm-hmm.
And then my answer will be 2. I agree with the 2. Because I didn't see, I must always write no.
Okay.
Hello, sir, can you hear me?
Lebo,
Yes,
Lebo, do you
sir.
agree? Do you agree with the
I
2?
agree. I agree, sir.
Thank you. Abdul.
Can you hear me, sir?
Yes, we can hear you. Your network, you seems to be having network problems there. Please speak a bit faster so that we can be able to help you out.
He's gone.
Mm?
Yeah, but I also
Mm?
yes, so
I'm struggling to hear Abdul. Can anyone hear him?
It's cutting.
No, it's cutting shape.
He can write on the chat. Why can't he write on the chat?
Okay, Abdul, please write on the chat. Then, let's say, from where I'm sitting, we all agree that our answer is 2. And then, Lungile, our answer
Yes.
is 2. Our answer, the way our answer was found in 23 is the same way that our answer was found in number 17. Do you agree or disagree?
No, I agree. The same. I can put the answer in the chat. I agree because I didn't. Let me show you. So what I did, or would you want me to go through how I got to 2, just so that I know I'm following the right way. Is that fine?
We haven't got a problem with that.
Okay. So what I did, right? Since it's sin x squared minus 1 over x minus 1, what I did was that whole argument, I times it by x plus 1 over x plus 1, right? And then it will give me sin x squared minus 1 times x plus 1 over x squared minus 1. And then if I take out x plus 1, it will give me x plus 1 over 1 times sin squared minus 1 over x squared minus 1, which will give me 1 plus 1, which gives me 2. Is that correct?
You did break.
Sorry?
You did break.
Oh, okay. I'll start again. So I times the question that was given to us by x plus 1 over x plus 1, right? And then it gives me sin x squared minus 1 times x plus 1 over all of it over x squared minus 1, right? And then I wanted to separate the x plus 1, which will give me x plus 1 over 1 times sine x squared minus 1 over x squared minus 1. And then when I put in the limit where x is approaching to 1, I have 1 plus 1, which will give me 2.
I agree with you.
Okay. So I was becoming
Please ask them whether they agree with you or not.
Okay.
From where I'm sitting, I agree with
I
you.
agree.
Okay. So am I becoming a skilled mechanic now?
Yeah, you're becoming a professional mechanic.
A professional.
Yes. We are happy. I'm happy that you are now becoming a professional mechanic, not an original mechanic.
Okay, thank you.
Yes.
Yes,
Thank
sir.
you. Hello, who's talking?
It's Lerato.
Yes, Lerato.
X squared minus 1 is a difference of 2 squares.
I agree.
So what if that angle there, you make it x minus 1, x plus 1, cancel out, use the rule, unfair rule, that rule. Yeah. Is it fine still?
Yeah. Whoa. You are now tampering with our angle. No, it is not even our angle. This is what we were given. Why are you tampering with that angle? There is nothing that level Lerato, I'm sorry. Lerato, please don't tamper with the angle. The angle is as it is.
How did he tamper?
Did you hear what he said?
I didn't.
He said, Level.
Yes, sir.
We do agree that x minus 1 is a difference of squares. This is what Lerato said. He said because x squared minus 1 is a difference of squares. X minus 1, the factors of x squared minus 1 are x plus 1 and x minus 1. Okay?
Yes, sir.
Now, according to him, the x minus 1 will also cancel with the x minus 1. In an angle.
So how did he got x plus 1 at the end, which is 2, while he cancelled that x minus 1 with x minus 1? How did he got that x plus 1 at the end?
I'm a miracle worker. How many times must I say?
No, you can't be a miracle worker. You saw this somewhere. I'm sure you saw this somewhere.
No, I didn't see it somewhere. Sin x minus 1. In front of it, I write x plus 1. And then it's going to be sin x minus 1, x plus 1. And then I cancel out sin x plus 1 over sin x minus 1 over sin x minus 1. That's 1. 1 times x plus 1. It's x plus 1. I work miracles. I always think 1 is 2.
Yeah. Okay, math is not a miracle. Bona, you can't get miracles more. You have to follow this. There's no miracle.
Mbongise's hand is up. I think he wants to assist.
So he wants to help with the miracles. Bonnie said, please come with a miracle.
Okay, it's at least me, I'm doing the cheating, not the miracle. Look, look.
Bonnie is the one who's always cheated.
I think the whole idea is to look at the easier way. And the easier way is not to mess up with the angle. Try to change anything else to look like the angle. Leave the angle alone. Try to change anything else to look like an angle. It's not going to be easy for you to try and change the angle. So you are right when you are saying x squared minus 1 is a difference of 2 squares. 100% correct.
Yes.
What you need to do now, change the denominator to be like x squared minus 1. And you can only do that by multiplying it by x minus 1. But now, x plus 1, I mean. But now you cannot just multiply by x plus 1 in the denominator only, because you will be now doing something else. So you need to multiply by x plus 1 over x plus 1, which is the same as 1 actually. Then you are now changing your denominator to be x squared minus 1. Then the theorem number, I can't remember what theorem is that, but it is the same thing that we've been doing. Then it's applicable, except that on the side, you still have that x plus 1.
I'm a bit confused, you know.
I agree with you.
Okay, who's
a bit confused?
Okay.
Yes. I'm a bit confused because from what I understand, I think you had at some point, right? You had limit as x approaches 1 of sine, and then whatever you had in your bracket over x minus 1, x plus 1. Yes, multiplied, that whole thing multiplied by x plus 1 over 1. Yes, no, maybe.
No. Multiplied by
x
x plus 1
1
over x plus 1, not over
Yes.
1. So it's x plus 1 over x plus 1.
But then you changed it again so that you have x minus 1, x plus 1, and then on multiplied, it's going to be x plus 1 over 1. The goal is...
I agree with you. Right.
Yes, but this is where my question is now. The limit as x approaches 1. Let me ask the question. The limit as x approaches 1 of sine x over x, what is that equals to?
0. Is equals to 0, my brother.
Check something out. The limit is x approaches of sine x squared minus 1 all over x squared minus 1. X squared, when you substitute 1, that becomes 0. So that means we are technically, as we plug in x, our denominator and angle approaches 0. So that means we are approaching 0 in a way. So that's 1.
Is it Sibusiso?
It's that. Yes.
How are you?
I'm fine, sir.
Good. Where have you been?
Hey, sir, I've been busy with other things. Say, I was trying to cover my assessment. Say, too much work.
Okay. All right, I understand. Welcome.
Thank you, sir.
So this is basically the proof that 0 over 0 is equals to 1.
Something like that.
No.
You see the light. You see the light.
I'm seeing the light, ne?
Yes, 0 over 0 is 1. No matter what they say, don't believe them. It's 1.
Okay. Anything over itself is equals to 1.
Sure.
That person is gonna make a mistake when we get to the point where we faced with 0 divided by 0.
Sine
and then when now is equals to 1.
So help me here because I'm a bit lost, eh?
Isn't anything divided by 0 undefined?
It is undefined.
You see now. You see?
Once upon a time, the square root of a negative number was also undefined.
But now it's fine.
Okay. Please allow me to say this. I was not in that workshop where it was said 0 over 0 is equals to 1. I was not part of that discussion.
I didn't.
Yes, I'm just trying to understand what happened there when we dropped the limit. from that step where we had sine x squared minus 1 over x squared minus 1.
Okay, can I explain for you? And then, look at sine. Okay, look at sine x squared minus 1 all over x squared minus 1. And then just look at that part only. Are you following?
Yes.
Okay.
Yeah,
Our
well.
x is approaching 1, right?
Yes,
Are you
I'm
still
following.
following? When you plug in 1, our denominator becomes 0. And our angle becomes 0, right?
Yes.
So as we plug in 1, our denominator approaches 0. So if you put in 0.5, we are approaching 0. If you put in 0.4, we are approaching 0. So as we approach 0, the limit of sine x squared minus 1 all over x squared minus 1 approaches 1, because when you plug in 1, it's the same as plugging in 0, because you say 1 minus 1. Do you follow then?
Yes.
Yeah. That's how we got 1. Because it's the same, but in a 0 is the same as 1 minus 1. So if we approach 1, when we minus 1, that's the same as we are approaching 0, because in an opposite direction.
Okay. No.
I don't understand. Yo, that one was too powerful. Yo. What's going on?
Yeah.
The electricity
Zero.
came back.
Now I'm lost. Which one are we talking about now?
This is
We are
what
talking,
this
we are
whole
talking
thing.
about sine x here.
What you were talking about is this. This.
Yes.
But now the
And
way
this is this. And that's it. Yes,
but now
Abdul.
0 over 0 is 1. Say, where is that one coming from?
No,
I
it's
don't know. That's
incorrect.
why I said it's not, I was not part of the workshop.
Yeah, you must forget about that one. 0 over 0 is undefined. No human can comprehend that number.
Hey guys, please excuse us. We are very fragile. Please.
It's internet. 0 over 0 means La Hospital's rule.
One hospital.
We can say interdominant.
The previous one does not have a hospital rule, so please.
Is everybody okay up to so far?
Yes, sir.
Yes, sir.
Is everybody happy up to so far?
Yes, sir. I'm happy.
I am happy. Also.
Anyone who is having any question?
Me, I'm not happy with 0 over 0 only. I'm not happy with that.
Forget about 0 over 0.
Please, Abdul. Okay, Abdul. Let's continue with 0 over 0. No. Let those who are dividing 0 by 0 continue with it in our absence. Then tomorrow we will continue. But the 0 over 0 will not form part of our discussion.
Amanda, comrade.
Amanda, comrade. Yes.
I'm sure.
On that note, let me thank everybody for joining and everybody for participating. Let's continue to work together to participate. This is how we all learn. I don't know what we're doing. I'm also learning. So let's see each other tomorrow to continue with our mission.
There.
Yes.
What are we covering tomorrow? Which topic?
Tomorrow we'll finalize a number of those questions. You see from that list of questions.
Or from 24, 25, 26.
Yes, from this, we'll look. Where was I now? let's say probably we can look at 22 up to the last one, because we dealt with number 23. No? Tomorrow we'll look at 22 and the remaining. Then from there, we'll talk about continuity. After yes.
Okay, so can I ask for a private session about squeeze theorem, so
squeeze theorem?
Yes, sir.
And no problem, my boss is in the session, then
okay, so I'll email her.
On that one, then please engage her.
Yeah. Yes, sir. I would like to join you guys on that matter.
Me too,
Method.
please. Me too, please.
You need to send me an email individually for me to group you, not session. But I need to talk to Glenn first tomorrow before we do that.